Hello everyone, we will start a new topic today, which is twist in yarn. So, we will discuss different aspects related to yarn twist, its importance, its effect and how to measure this twist. And we will also try to see some practical problems related to twist. Basically, the twist, it is a measure of the spiralness of the fiber. Okay. So, twist is the measure of spiral turn given to yarn, mainly basically it is a staple yarn we talk about, but also in to some extent in filament yarn we need to apply some twist for different purposes, but for staple fiber the twist is important, otherwise we cannot actually form the yarn. So, in order to hold the fibers for the staple yarn and in order to hold the threads for filament yarn or for the plied yarn, okay, maybe 2 ply, 3 ply. So, that is the requirement of twist, and this is primarily imparted to the staple yarn in order to hold the constituent fibers together. Okay. Otherwise, there will not be any strength, thus gives the strength of the yarn. Okay. Now, this is given during the spinning process of staple yarn. Now, let us see, this is a delivery roller, this is the drafting arrangement of a ring frame and it is coming from say roving package. This is roving package, the roving is coming, it is getting drafted, and at the exit if we see the fiber strands are like this. This is the fiber, very thin fiber strand with no twist. That means, we cannot form yarn, this will be disintegrated after applying any force. Okay. This is with 0 force, 0 breaking strength. So, this is not going to help. Although we have got the continuous strand of fibers, but we do not have any strength, when there is nothing we can actually, this will be held together. Now, here comes the requirement of twist. Now, twisting is nothing but to impart some lateral force on the fibers. And how do we do? We just rotate, keeping one end not constant, fixed, we cannot say it is fixed in the sense it is not rotating, one it may move laterally, but it is not rotating. If we impart, if we rotate other end, then this will impart certain twist, and in this way the fibers in the outer surface will have to travel a longer path as compared to the fiber in the core or inner surface. That means, the tension is higher on outer surface, fibers on the outer surface, that means due to its high tension at the outer surface, this outer fibers at the outer surface will impart inward force on the fibers inside that. Even the fibers in the next layer also impart force which will be less than this outer surface, but still it will have certain inward force. In this way this fibers will have some inward, it will generate some inward force due to the longer path and tension generated on the fiber. So, this inward force, what is it doing? This inward force increases the fiber, it acts as a normal force which increases the frictional. So, it will not allow the fiber to slide past over another fiber. On the other hand, in initial case when there is no twist, the fiber can easily slide past over other fibers. So, this will actually lock the fiber and ultimately it will develop certain strength. Okay. So, fiber will not slide over each other. Now, this is called the real twist. Now, another type of twist is there where suppose this is a strand, this is a strand or say filament. Okay. Now, here at this end we are not twisting, this is fixed, and this end again we are not twisting, this is fixed. We are imparting twist at the center in between these 2 points. Now, what will happen here, suppose A, B and we are trying to rotate at the C. So, between A and C the direction of twist will be in one direction, and in between C if it is say a positive direction, and in this side it will be negative direction. So, why I am telling it is a positive and negative, I will come back. This direction, the positive direction or negative direction, this has got specific term which is called S twist, S direction or Z direction, or S, this is Z. So, this is Z direction, this will be, this is S direction. So, this is actually it is not real twist, because when it moves, the yarn moves, this will get automatically cancelled out and finally, the yarn will be a 0 twisted, and this is called false twist. So, this false twisting principle is used in many applications, particularly for texturing, for many other applications where we do not need real twist, we need intermediate twist for some specific purpose. Now, when this fiber strand in ring frame this fiber strand after say drafting it comes out, so without any twist. So, we have to impart twist on this strand. Now, it is done by arrangement of it is a ring and traveler, we are not discussing this here. So, this is a guide and it will go through this guide, and there this is the called ring and it goes through the, this is traveler and here it is a bobbin. Okay. It is a bobbin and it goes to the. So, due to the, and here the spindle which rotates, and with the help of the yarn pull this traveler rotates. So, due to the rotation of the traveler there will be twist imparted on the yarn strand, and this twist is real twist, because here this at this end total bobbin, total spindle is rotating. So, this is imparting real twist, and here we can express this twist in terms of twist per unit length. And how do it express here? It is expressed in terms of basically it is a delivery rate, if it is V say meter per minute, okay, and its rotation here, this rotation of the spindle, it is say n s rpm, and if it is rotating, say it is a traveler n t rpm. So, then the one rotation of the traveler imparts one twist in the yarn. So, it will be basically the n t, okay, by v, v delivery, so v d. So, n t by v d is the actual twist imparted per unit length, but for all practical purposes. So, n t is actually it varies, and the all practical purpose after unwinding from this package. So, it becomes it is a n s by v d. So, all these details we can learn in other course, which is yarn manufacturing, but here the application, how to apply the twist in the staple yarn, it has been explained here. And for other technique, other spinning processes, the the twisting principles are different, but for staple yarn twisting is must, okay. And false twisting we have discussed. So, it is used for texturing, for many other applications. So, now the effects of twist in the staple yarn. So, as the twist increases, the lateral force holding the fibers together will increase, that we have explained. This lateral force will increase. So, the fibers contribution towards yarn strength will increase, and that, so that overall yarn strength will increase. But at the same time, as the twist increases, the angle that the fibers make with the yarn axis will increase. So, now suppose this is yarn, now here it is this is a fiber, okay. Now, another yarn with a high twist, now the when the load is applied on the yarn, the contribution of fiber strength towards yarn strength will be, if it is theta, that means the component of fiber strength will be, this is fiber strength. So, S fiber strength of fiber, its contribution will be towards yarn strength will be cos theta, that cos theta component will be on the yarn axis, towards the yarn axis. Now, here it is cos theta 1 and same fiber cos theta 2. Now, theta 2 is more than theta 1, that means for same fiber, due to this obliquity effect, the contribution of fiber strength towards yarn strength is low in this case. This is yarn A, yarn B. So, yarn B, as the cos theta is more, so here cos theta component will be less. So, this total contribution towards the yarn strength will be less in case of yarn B. Okay. So, this is yarn A, its angle is less. So, its contribution will be more. So, that is how. So, you will see here we have two different contributions. So, if we see, if we measure, so in x axis say amount of twist, okay, or twist angle theta, okay, or twist per inch, twist per length, twist per inch. So, in x axis, and in y axis if the yarn plot yarn strength, in the yarn strength we will have two components here. In one component, the due to the friction between fiber to fiber friction, the yarn strength increases. So, it will give us this value. So, with the increase in twist, this is the friction component. Okay. Another component is that due to, as we have explained just now, with the increase in theta or twist, the contribution of fiber strength towards the yarn strength will continuously decreases. So, this is the point where the actually this is the level of twist where these two curves are matching. Now, if we take the average, if we take the two effect of the both the factors, then we will see a curve like this. Okay. So, this is the nature of the curve, twist versus strength, that means it is increasing initially due to the increase in fiber to fiber friction, here it is dominating, and in after that, after reaching certain level of friction, we do not need any more friction because it has reached its optimum value. So, further increase in friction does not help, it will not actually prevent any sliding because already fibers are locked. Then comes the obliquity effect, which is due to this the strength of the yarn reduces. Okay. So, maximum strength which occurs when they are oriented in the direction of applied force. So, ideally the maximum orientation for filament yarn, so maximum strength will be with a 0 twisted, because all the fibers are oriented in that direction. So, towards so this is the nature as we have discussed just now. So, initially it increases, then after this is called optimum twist, the twist at which the strength is maximum. Okay. The twist value required for maximum strength of the yarn is higher than the normal use, since the increase in twist also has negative effect on the other important properties of yarn and fabric. Now, so this is the point, this is the level of twist where the yarn strength is maximum. Now, we do not reach up to this point in all most of the practical purposes, we do not reach up, because we always deal with this zone. We set our twist level somewhere between this in this zone, because as we increase twist, in addition to the increase in strength, there are various negative effects which actually which affect the characteristics of fabric and yarn. Now, what are these effects? Now, let us discuss in detail. Before that, so in continuous filament, as I have mentioned, a small amount of twist is required. So, in continuous filament, if we see the nature for this is for staple yarn. Now, for continuous yarn, if we see that the effect of obliquity effect, it reduces continuously, but initially when the filaments are parallel, so that is the 0 twisted case, and when little bit twist is applied, initially there will be a frictional assistance. So, that will increase the twist strength little bit. So, that is why the effective nature of the curve is like this. Initially there will be small increase, little increase, then it will drop. So, that what is the case in the case of the continuous filament. So, it is important to keep the filaments together, that is why we do not use the multifilament of 0 twisted, because it will create problem in next process like weaving, knitting, and so to keep the continuous filament together, we have individual filament together, we impart certain twist. So, as the twist increases, the yarn strength decreases below its maximum value at 0 twist level, that will keep on increasing, but because of the variability of individual filament strength. So, if we impart little bit twist, so it will average out. Okay. So, initial effect of twist is to support the weaker filament, otherwise the weaker filament will immediately break. So, to support and to enhance little bit frictional contact, so that twist is imparted. So, the nature is that it initially little bit flat, then it reduces. Okay. Now, the twist of the yarns are of two types, one is S twist and another is Z twist. This is actually it is easily one can identify based on the type of the alignment of the fiber. Okay. In the surface, if the fiber alignment is in this fashion, so it forms a S type fashion, then it is called S twist. If it forms the Z type alignment, then it is called Z twist. There are two different types of S twist, S twist and Z twist, and this direction, twist direction, this has got great impact on the various effects on the fabric. So, the effects are, first effect of twist is the fabric handle. Okay. Now, as the twist level in the yarn is increased, it becomes more compact. Okay. It becomes harsh, the yarn becomes hard. Okay. The fibers are held together, so giving harder feeling of yarn. So, if we want soft feel, soft touch, so we must go for a low twisted yarn. Okay. A fabric made of high twisted yarn will therefore feel harder. Okay. And it will be thinner, because high twisted means the diameter of yarn will be less. A fabric produced from a low twist yarn will have soft handle. Okay. But at the same time it will be weaker. So, that is how the problem is that with the soft twisted yarn. So, if we want a fabric with soft twisted handle, so we must apply less twist. So, it will give us the highly soft fabric. Okay. But if we increase the level of twist, the diameter will reduce and this will give the hard feeling, because the yarn is not compactness of the yarn, it is not compressible yarn, this yarn is compressible because of the less twist. But the main problem with this type of yarn is that, as this is the almost open structure, this is softer one, the fibers, whatever fibers are protruding, this fiber will be easily come out. So, this may result hairiness, and also this fiber will tend to have tend to roll down, and gradually as these fibers are not firmly gripped inside, this fiber will gradually come out from the structure, and then the hairiness, the peel, these are called peels will become larger and larger gradually due to the use, due to the movement, due to the force applied. So, suppose if we apply force here, there will be a rolling action on of the fiber, and this will tend to pull the other end of the fiber, other end of, and this the peel size of the peel will gradually increase, and this is actually very prominent. This phenomenon is prominent for low twisted yarn. But in case of the high twisted yarn, as the yarn structure is very compact, this will not allow the yarn fiber to come out easily. This will, so that this will not result the peeling. So, that is why the peeling tendency is more in case of low twisted yarn. And also the abrasion. So, the low twisted yarn, fabric made of low twisted yarn, the fibers easily come out from the surface or from the inside the fiber, okay, fabric. So, that is how it will result the weaker abrasion resistance, its abrasion resistance will be poor. And if we talk about the moisture absorption, the high twisted fiber actually yarn holds the fibers tightly, and it does not allow the moisture it does not allow the moisture to penetrate inside the structure. So, restrict water to enter inside. So, its moisture absorption is low. So, if we want to enhance the moisture absorption, we must use a fabric made of low twisted yarn. So, high twist in the yarn is used when a high degree of water repellency is required. So, there are various applications like gabardine fabric is one example, where we use high twisted yarn. So, that means it will give us the water repellency type finish. Sometime like in umbrella fabric, if we use the high twisted yarn, so it will not allow the water particle to come inside the fabric. So, that is how. So, water repellency characteristics also controlled by the twist, and low twisted yarn is used where absorbency is required, like wipes. If when we use a fabric for wipes, we will use low twisted yarn. So, by controlling the twist we can control the absorption capacity for a same fiber. Now, wearing property means how the fabric gets weared out. Okay. Now, with the increase in twist level, the wearing property like abrasion and peeling, as I have just mentioned, are improved. So, if abrasion resistance or peeling characteristics we have to improve, then we must use a fabric made of high twisted yarn. High level of twist help to resist the abrasion, as the fibers cannot come out easily. Okay. And the same effect also help preventing peeling, that I have just mentioned. Okay. So, it starts from entanglement, small entanglement, and gradually the entanglement gets bigger and bigger due to pulling out of the fiber from the structure, yarn structure. Okay. It gets rolled. Next characteristics is the aesthetic property. Now, aesthetic property, it is one of the aesthetic properties is that it is a shiningness. Okay. The level of twist in yarn alters the appearance both by changing the thickness or by light reflection. So, the fabric with low twisted yarn will have uniform reflection, whereas in case of the high twisted yarn, that will start reflecting the yarn with the reflecting the light of that, it will scatter the light, like a fabric made of say 0 twisted yarn and another fabric is made of say high twisted yarn. This will actually reflect light, uniform reflection will be there. So, that will give the shining nature. but here this will with as high twist that will start scattering the light at different angle. So, this will result the dull nature of them. So, this is actually this we can get we observe here if we use a fabric made of filament without twist, twistless filament, and another fabric from the same filament, but twisted filament. Twisted filament fabric will give dull look, and the without twistless filament fabric will give a shiny nature. This effect we can observe also fabric made of compact yarn or another is normal yarn. Compact yarn main advantage is that in compact yarn as there is no hairiness and fibers are parallel, okay, and so most almost aligned. So, compact yarn we impart less twist. So, as its less twist is imparted, so it results shining nature. So, compact spun yarn is actually shining, it is more the aesthetic characteristics is better. So, better light reflecting properties, and also different patterns can be produced in the fabric by using similar yarn, but at different twist level. Like if we have a say pattern, say stripe of say different twist, then we can generate different pattern. Now, we can see suppose we have two yarns, two types of yarn, say 4 yarns of say this is red is high twisted, this is high twisted yarn, and blue is say low twisted. So, this will high twisted and low twisted, and light will get reflected in different way. And if we design, if we same yarn with the different twist will give very nice shadow effect. This type of arrangement, this type of effect we can also get by having say this is say S twisted. So, few S twisted yarn, four say S twisted yarn is placed in the stripe, and 4 another 4 yarn of say Z twisted. So, this stripe will give a light reflection in different way than this stripe. This is called twist shadow effect, okay. And this is very actually popular, it is widely used in worsted suiting, The shadow stripe can be produced by weaving alternate bands of S and Z twisted yarn. Okay. Level up twist can also be used to enhance or subdue the twist effect, twill effect. So, if we have say Z twill fabric and if we use Z twisted yarn, then it will give a enhanced Z twill effect. Similarly, for S twill, so if we use S twisted. Okay. So, that is how we can actually enhance the effect, aesthetic effect of a particular fabric. Now, cover factor and transmission characteristics. Transmission means air, moisture or thermal heat transmission. So, as twist increases, diameter of yarn decreases, and because the diameter decreases keeping everything constant. So, its covering power will reduce. So, there will be more and more pores, and that will result the higher air transmission. So, that means air permeability increases with increase in twist, and transmission characteristics it affects. So, air and moisture vapor permeability increases, and it also affects the wicking characteristics, because with the increase in twist the wicking, that means transmission of liquid decreases, because the fiber, the water has to travel a longer path. This is yarn, suppose fibers are parallel, and during wicking the water will actually transmit along the capillary, but once there are twist, high level of twist is there, the water has to travel along the curved path, okay, helical path. So, the wickability, the wicking speed gets reduced, okay, and thermal transmission. So, as the twist increases, the entrapped air inside the structure reduces. So, thermal insulation effectively reduces with the increase in twist. Okay. So, we have seen that if we actually can incorporate entrapped air inside the structure. So, if we for thermal insulating cloth we must use low twisted yarn. Now, there are few practical applications where we use high twisted yarn and to get certain specific nature, specific characteristics of fabric. Like here we will give two examples which are very commonly used, one is georgette, another is chiffon. Both of them are having high twisted filament here, made of filament normally, it is a Z and S twisted in x axis warp and weft, okay. And chiffon has got having little bit higher twist, it is almost double, okay, here, but these two types of fabrics are actually known for the high twisted yarn, okay. And twist shadow effect, as I have mentioned in worsted suiting, is there. Now, georgette, coming to the georgette and chiffon, if we see here, this is georgette fabric, it consists of high twist continuous yarn in both warp and weft, having small crepe type of structure on surface. This is georgette high twisted, and chiffon, it consists of warp and weft, that it is again continuous filament high twisted, and it is called waryu in Japanese, okay. Maybe it is in that is the term they use. Now, if we see the term, it is koshi in Kawabata evaluation tester, where it is a stiffness of fabric. Now, here what we have compared with the fabric without twist, like taffeta is the fabric is made of continuous filament, okay, without twist. Now, here if we see that with the effect of twist, the georgette and chiffon has got much lower stiffness than the taffeta which is made of the twistless wave. That means, the twist has got its effect by changing the twist level, we can actually control the stiffness of fabric. If we want lower stiffness of fabric, limpy fabric, we must go for the higher twisted. So, if we increase the twist, the fabric becomes limp. Similarly, if we want crispness, some filling which is crispness filling, in that case we have to go for high twisted. We can see the georgette fabric or chiffon, they are having very high crispness. So, the fabric handle or fabric feel can be controlled by changing the level of twist. Okay. Now, we have discussed the bending rigidity. You can see here the bending rigidity, here it is a much lower than the twistless filament. Flexibility also increases, it is more flexible. So, if we want high flexibility, then we must go for higher twisted yarn, but flexibility in the sense of bending of the yarn, it is not in the sense of other thing. Okay. So, it is a flexibility, the bending characteristics we can improve. Now, coming to the most important characteristic, which is the level of twist. How to actually express the level of twist? Typically, it is very simple, it is a term, it shows it is a very simple term. Level of twist means you measure the twist in per unit length, okay, that is okay. So, the level of twist is usually expressed as the number of turns per unit length, that is twist per meter or twist per inch or twist per centimeter, but it is not the end of the story. It is actually twist per meter. If we express, it is not telling everything. So, there are something else. So, however, the ideal amount of twist varies with the yarn diameter. Now, the term came yarn diameter, then it is making the things complex. So, for different yarn diameter, if we impart same twist, then we will not give the same effect. Okay. The thinner the yarn, the greater is the amount of twist that has to be inserted to give the same twist effect, same effect. What is the effect? Same effect. Now, the effect here is that we want the effect which is the same feel, same touch, same hardness of the yarn, and that is actually, that is something else, that by imparting same twist we cannot achieve the same effect. Here the yarns are, if the yarns are of same different diameter, though, so we cannot impart the same twist TPI or TPM to get the same effect. So, we have to impart different twist per unit length, different level of twist. So, that the factor that determines the effectiveness of the twist is the angle of twist. So, we must keep the twist angle constant, so that we can get the same effect. So, it is not the twist per unit length, it is the angle, twist angle of yarn, twist angle of fiber in the yarn, that controls the effect, that controls the all the effect. It is not the only the strength, only the hardness, it controls everything. It controls the shining nature, it controls the fabric handle, everything. Okay. So, this is the twist angle, but main problem of twist angle is that it is very difficult to measure. The simplest way of measurement is the twist per unit length. Okay. So, if we can measure the twist per unit length, which is measurable, and if we know the diameter of yarn, then we can get idea about the twist angle. Okay. Now, we will see, we should very carefully we can observe here, this is one the yarn of diameter d, let us consider yarn as a circular cross section, okay, of diameter d, and here the this red color it is a fiber, okay, one fiber here it is a wrapped around that, it is a surface fiber. Now, this is yarn of diameter d, and one fiber has taken turn of one full turn it has taken. That means, it has twisted once. Now, this length, suppose it is a L length. Now, once it is twisted, this is one. Now, if the twist per unit length is T, as we have mentioned TPM or TPI, this is the T1. Okay. Now, that means, for one twist this length will be 1 by T, that is nothing but L. Okay. Now, this if the diameter is d, so let us take its capital D, and this if it is a circular in cross section, yarn is circular in cross section. Now, imagine we are now just opening up this portion. So, we are making it flat, it is opening. This is the situation here. So, this length, this width become pi d, and this fiber which has actually angle of twist, if it is theta, if we totally open, then it will become, this angle will become theta. Okay. This is the twist angle. Now, if we want to measure the twist angle theta, so here tan theta will be pi d by L, okay, and 1 by L equal to T. So, we can write pi d T. T is the twist per unit length. Okay. Now, so the fiber makes an angle theta with the yarn axis. Okay. Now, here tan theta equal to pi d by L. So, at effectively it is pi d t. Now, the tan theta is proportional to the d diameter of yarn and turns per unit length T, as I have already mentioned. So, in the indirect system of yarn count, the diameter is inversely proportional to the under root of yarn count. So, tan theta is proportional to turns per unit length divided by under root of count. So, tan theta pi d t, and T is the twist per unit length, theta is the twist angle. Now, the T twist per unit length from earlier one. So, d tan theta equal to pi d in multiplied by T, T is twist per unit length, d is the diameter of yarn. So, T what is that? It is a 1 by constant under root c. Okay. Now, here if we see the tan theta equal tan theta T equal to tan theta by pi d, from there we are getting one parameter, this parameter which is exactly it is a constant parameter. This is the parameter which is constant parameter, and this we can see here, actually here it will be c by c is the c by under root n. Okay. This c will be this, there will be c by under root n, it will be. So, effectively this is the total c tan theta by pi, this is total constant. Okay. This constant is known as the twist multiplier. This is the constant, that means the twist multiplier k, it is nothing but c is a constant factor, pi is constant factor and theta, that means twist multiplier it is a proportional to the tan theta. If we can measure the angle, then we can calculate the value of theta k value, and as the tan theta, the theta cannot be measured easily. So, we can get the this k value indirectly by measuring the yarn twist level and yarn count. So, the general formula is that T in the indirect system, the twist per unit length equal to the twist multiplier by multiplied by under root count. Now, the implication of twist multiplier. Now, what we have seen, T equal to k under root n, that means T p I equal to k is nothing but twist multiplier under root n English count. This is the indirect system of measurement. Now, here the thing is that if we want to use the finer count, want to produce finer count, suppose we are producing one yarn of 16 count, 16 NE, another is say 25 NE, another is say 36 NE, like this. We are producing 3 count, this is coarser, medium and finer count, and we are imparting same twist say 20 twist per inch we are imparting. In that case, the yarn 1, yarn 2, yarn 3, in the yarn 1 what are we getting? 20 Tm under root 16, that means Tm will be 20 by 4 5 Tm. For say 25 count yarn, we are imparting the same level of twist, same TPI of 20. So, for 25 count yarn, what will be the Tm value? Tm 1. So, Tm 2 will be 20 by under root 25. So, it will become say 4, Tm becomes 4. Now, for say 36 count, Tm 3 will be 20 by 6, it will be somewhere around 3 point something 3 point. So, as we have seen here, keeping the twist level same, if we increase the, if we make the yarn finer and finer, then we are getting lower and lower Tm. What does it means? What does it mean Tm? Because these are, that means we are getting the yarn, that fiber angle, twist angle, it is gradually reducing. So, for same twist level imparted, same twist per unit length imparted, if we produce the finer count, the angle of twist will reduce, and that angle of twist reduction means yarn becomes softer and softer, and the softness of yarn is reflected by twist multiplier. That means, twist multiplier is a parameter which actually reflects the hardness of the material, hard hand of the material. It does not give idea about the twist per unit length until and unless we know the count of the yarn. So, if we know the count and twist multiplier, then we can get the twist per inch, but twist multiplier concept is entirely different from the twist per unit length. Twist per unit length gives its a physical measuring characteristics. It is a physical parameter which can be measured in yarn, which can be measured, but the twist multiplier, it gives the inner feel of the yarn, okay. What is there inside the yarn, and that indirectly reflect the twist angle, okay. So, that is why twist concept of twist multiplier is extremely important, and this is the way we can calculate. So, we cannot calculate tan theta, we do not have the idea of the C value, constant value for yarn. So, we indirectly can calculate with the measurable parameter which can be easily measured, the twist per unit length we can be measured and the yarn count can be measured. So, so we can get idea of twist multiplier. So, what we have discussed till now, it is a indirect method. Indirect twist multiplier is in direct twist multiplier, it is a K equal to TPM multiplied by twist, okay. And in indirect we have mentioned K equal to TPI by cotton count. So, in that way we can get the twist multiplier, and which is the idea of twist angle, okay. So, twist factor is defined as the twist per unit length divided by yarn count, that is the in indirect system, and direct system it is a twist per meter or twist per centimeter and yarn takes. Now, if we want to know, now see for direct system what we have seen, the takes twist multiplier is the, it is called takes twist multiplier, twist say twist factor say or constant, it is called it is K, it is nothing but twist per TPCM and multiplied by under root takes. So, the unit of twist multiplier in direct system will be TPCM multiplied by takes to the power half. This is the unit we use for direct twist multiplier. So, for direct count it is there, twist per centimeter equal to twist factor divided by twist the under root NT, okay. So, the unit of twist factor is TPCM multiplied by takes to the power half takes. So, that is the, okay. Now, we will stop here, and related to this all this twist multiplier and twist factor, we will see different numericals in next class. Till then, thank you.